Here is another video that will help you get ready for the 1.1 to 1.3 quiz in calculus, and this time it's not visual. These are completely analytical examples. I have 3 different ones showing you the 3 different types that we did analytically in class. When you go through these, the first thing you want to do is make sure you can try direct substitution, because there are problems that are easier than they look. So what I mean by that is, on this one, the first thing you want to try is take that -3, plug it in for x, and see if you do get an answer. If to shortcut, always check the bottom first, because that's usually where the problem is going to occur. So if I put -3 into that denominator, I'm going to get -3 squared plus 2 times -3 minus 3. I do get 0, and I end up with that 0 over 0. We call that an indeterminate form. So my techniques are to rationalize, to factor, to try to do an algebra to combine, in this case it's only one fraction, or to use our special trig limits. In this case, obviously, we need to factor. So I'm going to factor the top and the bottom as much as I can. In the numerator, I can take out an x, which leaves me with x squared plus x minus 6. In the denominator, I'm going to go straight to FOIL factor. I get x plus 3, x minus 1. Not done yet. I can still go further with my numerator. I want to factor fully. I can get that numerator to be x plus 3, x minus 2, and then the bottom was already done at x plus 3, x minus 1. You want to cancel your like factors on top and bottom. Now that you've done that, now you want to see if can you directly plug in -3. So now when I plug -3 in, I get -3 when I put that in for x, times -3 minus 2 is -5 over -3 minus 1. I get 15 over -4. That cannot be reduced. You're going to keep it negative, keep it improper, and that one is finished. The next problem. When you look at this one, hopefully that radical is a good indication that you need to rationalize. And the way we rationalize is we take the piece that has the radical in it and we multiply top and bottom by its conjugate. The conjugate is the exact same binomial with the opposite sign in between. So it's going to be the square root of x plus 2 instead of the square root of x minus 2. On the top, I'm not going to do anything. I'm going to leave it as x minus 4 and the conjugate, because we saw so many in class and you can kind of see what ends up happening when I simplify. On the bottom, when I go to FOIL it, I only need to do the first and the last, because the outer and inner cancel. So if you think about the letters in FOIL, you're only doing the FLA, the F and the L. So square root of x times square root of x is x, and -2 times +2 is -4. And what you've done now is create a factor that is on the top and the bottom that will cancel. Now when you go to put 4 in, you get the square root of 4, which is 2, plus 2, which is 4. Finally, the third one. First thing I would try with any trig, put in the number directly. So if I put 0 in, the tangent of 0 is 0, the 0. So we do have this indeterminate or undefined form. We do not have any special trig limits for tangent. We only have 2. One is with a sine and one is with a cosine. When you see tangent, you want to use a basic identity. And the identity that you want to use, come off to the side and write it, is that the tangent equals the sine over the cosine, because that puts it in all the trig functions we're used to using. So I'm going to continue with the limit, but I'm going to write it as the sine of 4x over the cosine of 4x. The angle doesn't change in this identity, so it started as 4x, it has to stay as 4x. And it's still divided by x, but instead of writing that, I'm going to write it as times 1 over x. You know that x has to be in the bottom. I'm going to kind of keep it off to the side and put a 1 over x. You could put the whole thing divided by x, and then you multiply by the reciprocal, and you end up there. We have a special trig limit that deals with a sine over an x. So these pieces need to go together. So I'm going to do some rearranging. I'm going to take the sine of 4x and put it over the x, and then I'm going to write down what's left in a second fraction, a 1 over cosine of 4x. Still have not changed the meaning of what's there. I just rearranged things for my purposes. Finally, I almost have a special trig limit. Sine of 4x over x is very close. What's missing, and I'm going to change colors so you can see what I added in there, is I need a 4 down here. I'm allowed to introduce a 4 in the denominator as long as I also introduce a 4 in the numerator, so I didn't change that fraction. What I have now is I have a 4. This special trig limit is equal to 1. It's one of the 2 special trig limits you should know. And then finally over here, I can do a direct substitution here. I can plug 0 in, because the cosine of 0 is 1. So I have 1 over 1, which is 1. When I multiply all of my factors together, I get a limit of 4. So here's 3 examples: a factoring, a rationalizing, and a special trig limits that will all be in the analytical section of your quiz.